Hello seniors, today we're going to see electronic assignment 23, which is more on indefinite integrals. We're going to learn two new rules for finding integrals of logarithmic functions and of exponential functions. So the objectives for today's class: number one, calculate the indefinite integral of x to the power of n. Let me change this. This is the one we have already seen. This is the one we're going to see today, 1 over x, and e to the power of x is also one we're going to see today. Integrate the composites of any of the previous functions with the linear function ax plus b, and finally integrate by applying the method of inspection or substitution. I'm going to show you what that is about in a second. Okay, so let's start with this small challenge here. It says, what is the integral of x to the power of -1? If we try doing the integral of this by the method we already know, we're going to say that the integral of x to the power of -1 dx is equal to, we raise the exponent by 1, so this is x to the power of -1 plus 1, that's 0, divided by 0. But if you remember, any number divided by 0 is undefined, right? So I'm going to write plus c because this is an integral. So this is undefined. We can never have 0 as our denominator. So for this particular integral, you should remember that when f of x, the function was natural logarithm of x, the derivative of this function was 1 over x, if you remember from derivatives, right? So that means that if I integrate this expression, which is exactly x to the power of -1, let me write that here. Remember that x to the power of 1 is x to the power of -1 is the same as saying 1 over x, right? dx. So if my function is 1 over x and I want to integrate this function, I should get as a result natural logarithm of x. Okay, so with this information, we can find the integral and say that the integral of x to the power of -1 dx, which is the same as saying the integral of 1 over x dx, is equal to natural logarithm of x plus c. And this would be the correct answer for this integral, okay? Then it says, you have seen that the derivative of natural logarithm is 1 over x, which is the same as saying x to the power of 1, for x greater than 0. So the integral of 1 over x is natural logarithm of x plus c. And if we use the same reasoning, if you remember the derivative of e to the power of x, the derivative of e to the power of x is e to the power of x. That means that the integral of e to the power of x would still be e to the power of x plus c, okay? So these are the two new rules you're learning today. The integral of 1 over x is natural logarithm plus c, and the integral of e to the power of x is e to the power of x plus c. These two rules for integration are both in the formula booklet, okay? Let's see these examples in order to ground the concept. It says, find the indefinite integral. We have for part A, we want to find the integral of 4 over x dx. To do this, it'll be convenient that, for example, we take the 4 out of the integrand, put it outside since it's a constant number. So this is the same as saying 4 times the integral of 1 over x dx, right? And we already know, but by what we just learned, that the integral of 1 over x is natural logarithm of x. So this would be 4 times natural logarithm of x plus c. Don't forget the plus c. And this would be the answer for this particular integral. Remember, you can always check your result if you want. If I find the derivative of 4 natural logarithm of x plus c, if I calculate the derivative, we're going to say that this is equal to 4 times the derivative of natural logarithm. If you remember, the derivative of natural logarithm is 1 over x. And then the derivative of c is 0, right? So we don't need to write that. So this is, if we organize this would be 4 over x. And 4 over x is exactly what we had at the beginning of the exercise, okay? That means that our integral is correct. Let's move on to part B, which says find the integral of e to the power of t divided by 2 with respect to t. Okay? So we can do the same thing here. We can take this 2 out of the integrand since it's a constant number. Remember, if we take it out, it will be out as 1/2, right? Because the 2 is in the denominator, times the integral of e to the power of t dt. And from the rule we have just learned, the integral of e to the power of x is e to the power of x. That means that the integral of e to the power of t must be e to the power of t. So this is 1/2 times e to the power of t plus c. Don't forget the plus c. And that's it. This would be the result for this integral. As always, we can do the checking by finding the derivative of this expression. So we're going to say that 1/2 e to the power of t plus c derivative is equal to, the derivative of e to the power of t is e to the power of t, so it's 1/2 e to the power of t. Derivative of c is 0, so we don't need to write that. And you see that we're getting exactly, if we rewrite this as e to the power of t divided by 2, we get exactly the same expression we had at the beginning of the exercise. That means that we're doing this correctly. Okay, so these were two simple examples of how to apply this new integral rules. Now let's see some a little bit more complex examples. Example 5. It says find the indefinite integral, and we have these 3 expressions here. Okay, whenever I have these types of problems, I should first try to think if I can simplify something in order to make the integral a little bit easier. For example, in part A, we have the integral of x squared plus 1 squared with respect to x. One thing that I'm thinking about doing, which will make this much easier, is to expand this expression. Why expand this? Because there's no rule in when working with integrals, there's no chain rule like we had in derivatives. So we cannot apply any type of chain rule here. We would have to expand this and then solve the integral normally, right? If we expand this, remember this is the same as saying the integral of x squared plus 1 times itself, right? Times x squared plus 1 with respect to x. Why? Because this was squared, right? So if I expand this using FOIL method, I will have the integral of x to the power of 4 plus x squared again plus 1 with respect to x, right? So if I simplify this, I see I can add these two like terms. So this would be the integral of x to the 4th power plus 2x squared plus 1 with respect to x, right? And this is an expression that we already know how to find its integral, right? We can just separate the terms and find the integral of each of these terms separately, right? So if we do that, we're going to get as a result, for the first term, it would be x to the power of 5 divided by 5. For the second, it would be 2x cubed divided by 3. And for the third, it would be the integral of 1 is just x. And don't forget the plus c, right? So this would be the result. This is the result of this integral. So you see that we actually used the first rule we learned for integrals. We did nothing else. But we had to expand this expression before doing so in order to convert into something that we know how to integrate. Okay? So let's see part B. Part B says the integral of all of this expression. So let me write that down. The integral of 3x squared plus 2x plus 1 divided by x. As I told you for chain rule, when we talk about integrals, there is no quotient rule as we had with derivatives, right? So I cannot apply any quotient rule for integrals because that doesn't exist. What I see I can do here is, for example, separate the division, right? And divide this divided by x, then 2x divided by x, and finally 1 divided by x, and separate the terms and I will have something that I will be able to integrate. Okay, so if I do that, this would be the integral of 3x squared over x plus, it should be a parenthesis here, plus 2x over x plus 1 over x. I can do this separation, and this is all with respect to x. So I see that I can simplify terms. For example, x with 1x here, the x goes with this x, and this one stays like this. So I'm going to find the integral now. The integral, if I simplify this, it would be integral of 3x plus 2 plus 1 over x dx. Plus 1 over x dx. This is the expression that I need to integrate, right? And I already know how to integrate this. So we're going to write that this is equal to, let me copy this. This is equal to the integral of 3x, that's 3x squared over 2. The integral of 2, that's just 2x, sorry. And finally, the integral of 1 over x is the one we have just seen in this class. The integral of 1 over x is natural logarithm of x. And don't forget the plus c. So this would be the integral of that whole expression, you see? We can convert this into simpler expressions just by doing some algebraic previous process. Finally, for part C, we want to find the integral of the natural logarithm of e to the power of 2t minus 1 with respect to t. Once again, I should start by thinking if there's a way I can simplify this expression. If you remember from properties of logarithms, whenever I have an exponent inside my argument of the logarithm, I can take this down to the front and work it like that, right? So we can rewrite this as the integral of 2t minus 1, I take down the exponent, and then we have times natural logarithm of e, and this is with respect to t. And if you remember, the natural logarithm of e is always equal to 1, right? So we simplify this expression and we say that this is the same as saying the integral of 2t minus 1 with respect to t. And this is something easy to integrate, right? The integral of 2t would be 2t squared over 2 over 2. And the integral of negative 1 is t, right? So minus t plus c. Don't forget the plus c. And that would be the result. I see that I can, for example, simplify 2's here. So our final answer would be, t squared minus t plus c. T squared minus t plus c. That would be the integral of this expression. Okay? So, now we're going to see one last set of examples where I'm going to show you a kind of new method to find integrals, which is kind of similar to a chain rule. And it'll be very helpful to solve various types of integrals. So it says, find the indefinite integral. And we have 4 examples there. So, for part A, it says, the integral of 3x plus 1 to the 4th power with respect to x. Okay, if you look at the first exercise here, what we did here was just expand this expression, right? In order to get this simple form, which I know how to integrate, right? Now, the problem here is that I have to the 4th power. So trying to expand all of this will take up a lot of time, okay? So I'm going to show you a shortcut in order for you to avoid expanding this expression that will consume a lot of time, right? And this method is called the substitution method, which you will be using a lot for integrals, okay? So let me show you what the substitution method is about. So I'm going to write here, by using substitution method. The substitution method is kind of similar as the chain rule, as I told you. What we do first is we define a variable u. We do a change of variable according to what we need to do, right? So in this particular case, I'm going to define u, our new variable, as whatever I have inside the parentheses, which would be 3x plus 1. Then, after I define u, I'm going to find the derivative of u with respect to x, which means I will differentiate this expression over here. If I differentiate that expression, the derivative of 3x plus 1 is just 3, right? The derivative of 3x is 3, and the derivative of 1 is 0, so we don't need to write that. And then the next step, the last step actually, before replacing the values, is to solve for dx. I mean, leave the dx alone. If I leave the dx alone, we'll have that du over 3 is equal to dx, right? Why do we leave dx alone? I'm going to show you now why. If we go to our original expression, let me use colors for this. You see that we have, for example, dx right here, okay? So I'm going to be replacing that equivalent value for this, which is du over 3. I'm going to convert all of the integral in terms of u instead of in terms of x, right? So then all of this part, what I define as u, which is 3x plus 1, I'm going to be replacing it by this. I'm going to replace 3x plus 1 by u. So if I rewrite this expression, we would have that the integral, and instead of writing 3x plus 1, I'm going to write the equivalent, which is u. The integral of u to the power of 4, and instead of writing dx, I'm going to write its equivalent, which is du over 3. So du over 3. So this is our new integral. And you see that this is a much simpler integral. We know how to find the integral of this type of expression, right? We could say, we can take out this 3, for example. We will have 1/3 times the integral of u4 du. And we already know how to do this. So this would be 1/3. The integral of u4 is u5 over 5, right? And then the plus c. So we're almost done here. We already did the integral, but since our original exercise was in terms of x, I need to change again this variable for its original expression, which was 3x plus 1, right? So that's the only thing I need to do here. Rewrite this as, I can multiply this 2, and I will have 1 over 15. And instead of writing u, I'm going to write its equivalent, 3x plus 1, to the power of 5, right? Because it was u to the power of 5, plus c. And this would be the result for this integral. So you see how we could find the integral, which was a very simple integral, by doing a change of variable, which is known as the substitution method. You're going to be practicing with this a lot later on, okay? Now let's see part B. We want to find the integral of e to the power of 2x plus 5 with respect to x. Again, this is kind of, as I told you, this is kind of a chain rule, right? Because we need to define, in this case, the exponent as our new variable, and then see what happens. So I'm going to do the same thing by using substitution method. We're going to define u. In this case, u would be our exponent, okay? So 2x plus 5. Then I will find the derivative of u with respect to x in order to make the variable change. And this would be 2, right? 2 plus 0, we don't need to write plus 0. So that means that du over 2 is dx. So I substitute all of that into our equation. And we will get that This integral is the same as saying the integral of e to the power, instead of this exponent, we're going to write u, e to the power of u. And instead of writing dx, we're going to write its equivalent, which is du over 2 times du over 2. So I see that I can take this 2 outside of the integral. This would be 1/2 times the integral of eu du. We already know what the integral of e to the power of u is. It's just e to the power of u. So this is 1/2 times e to the power of u plus c. So we're almost done. The only thing we need to do here is rechange the variable to its original expression. U is 2x plus 5. So we replace this and we would have that it's 1/2 times e to the power of 2x plus 5 plus c. And this would be the integral of this expression. Okay, I hope this is getting clear for you people. Now let's move on to exercise C. Exercise C says the following. The integral of 3 over 4x plus 1. 4x minus 2, sorry. 4x minus 2 with respect to dx. Okay, let me check. Yes. So, just by observing this, I see that I cannot apply any rule for finding the integral of this. And as I told you before, there is no chain rule in integrals. So I will have to find a way in which I can solve this. I remember that, for example, the integral of 1 over x is equal to natural logarithm of x. So maybe if I do a variable change down here, I will be able to obtain something that when integrating will give me natural logarithm of something, okay? So that would be my substitution here. I'm going to, again, use this method, the substitution method. And now we're going to call the denominator of this expression, we're going to call u. So u is equal to 4x minus 2 in this case. Then, if I find the derivative of u with respect to x, this would be equal to 4 plus 0, right? We don't need to write plus 0. So du over 4 is equal to dx. So then I will replace the equivalent values. Instead of writing this expression, I'm going to write u. And instead of writing dx, I'm going to write its equivalent expression, which is du over 4. So the integral would be integral of 3 over u, and instead of dx, it's du over 4. So I see that I can take all of the numbers outside of the integral, so this would be 3/4 times the integral of 1 over u times du, right? And we know how to integrate this expression. The integral of 1 over u is natural logarithm of u. So this is 3/4 times natural logarithm of u plus c. And finally, I need to make the variable change again, right, to its original expression. So I'm going to say that the integral is 3/4 times natural logarithm of 4x minus 2 plus c. And this would be the final answer for this integral. Okay. Finally, we're going to see one last example, example D, which says the following. The integral of 1 over 6x plus 3 to the 4th power. Okay, so this looks a little bit more complicated. Let's see. So the integral of 1 over 6x plus 3 to the 4th power with respect to x. And, okay, first thing I need to realize is that I do not have any rule for finding the integral of this. I would have to make a variable change in order to be able to do the integral. So, again, we're going to be using the substitution method. This one over here. So by using the substitution method, I'm going to call whatever I have inside the parentheses, I'm going to call this u. So u is equal to 6x plus 3 in this case, Then if I find the derivative of u with respect to x, this would be equal to 6. So finally, du over 6 is equal to dx. So I'm going to make the replacement into the integral. So we're going to say that the integral of 1 over, instead of 6x plus 3, we're having u to the 4th power. And instead of dx, we have du over 6, right, according to this. So if I take out the numbers from out of the integral, we're going to have that this is 1 over 6 times the integral of 1 over u 4th. Actually, I see that I can rewrite. In this case, we're going to be working with the first rule of integral we saw, right? We can take the u up, so this would be the integral of u to the power of negative 4 du, right? And we know how to integrate this expression. It's 1 over 6. We increase the exponent by 1. Negative 4 plus 1, that's negative 3. So times u to the negative 3 divided by negative 3. And then plus c in order to finish. So we need to make the variable change once again in order to get our final result. So this would be equal to, I can multiply 6 and negative 3, that's negative 18. So minus 1 over 18 times, instead of u, we're going to write 6x plus 3, which was the original expression according to this. This is all to the power of negative 3, and then plus c. And this would be the answer for this particular problem. Okay, so you see how useful this substitution method could be. It will help us solve any type of integral. So I think that's it, yes. So that's it for this tutorial video. I hope this was clear. If not, please let me know. We're going to clear doubts in future live sessions. Thank you for your attention and see you.